Hello, everyone, and welcome to The Vertical Space, a podcast at the intersection of technology and flight. We are your hosts, Jim Barry, Peter Shannon, and Luka Tomjanovich, and here we look at the most important forces shaping the market of advanced air mobility with a particular focus on why and how they matter to those building a business in this very exciting and growing industry.
Hey everybody, welcome back to The Vertical Space. So today's going to be a different conversation, resembling more of our original podcast where we discuss topics between the three of us. The center point of our conversation are the comments we made after being asked to speak at Honeywell's second annual Advanced Air Mobility Summit. We started our talk giving a bit of background on why we started the podcast and how surprised and thankful we are it has taken off the way it has. Then, before introducing the 4 takeaways from the last few years, Luka will give some background on the last 100 or so years and the environment that we believe has set the stage for today's advanced air mobility. Then we talk about 4 takeaways from our experience with the podcast coupled with our own observations. We from the Vertical Space were honored to be invited to speak at the Honeywell Summit. Honeywell is moving our industry forward in a positive way, so we felt it special that we were asked to attend and speak. We mentioned that before we started the podcast a few years ago, we felt that those who are knowledgeable about and have deep experience in transportation, regulation, aviation safety, community acceptance of technology, and the military needed to be married to those advancing technologies in UAM, UTM, UAS, what we've generally come to call advanced air mobility. That there existed a very real information, talking, and listening gap that needed to be bridged. To be sure, there was a great deal of information flowing from individual actors in the space, but their views were not sifted and sorted and moved through collaboration into an actionable framework for policymakers, decision makers, innovators, and investors. And by bridging this gap, we believed the right advancements could be made and those not ready for prime time could be sharpened or parked. So during our podcast talks, we hope we have and continue to shine a light on what might become the best path forward. Not by any predilection from the host of The Vertical Space, but that the belief that competent, informed, experienced, direct conversation is worthwhile for moving the industry forward in a positive, faster way. So we hope we and our guests have closed the information gap, and we continue to help, and thanks for your support. The response to the podcast has been unbelievably positive, and we've done nothing to get the word out. The reality for us is that we've grown through an effort that simply allows people to discover. And as you, our listeners, find it has value, that you in turn bring others to the table. So thank you.
This episode of the Vertical Space podcast is brought to you by UAvionics. UAvionics is the leader in low size, weight, and power certified avionics for manned, unmanned, and advanced air mobility aircraft. Let UAvionics help you achieve your goals, whether that be type certification, airspace access, or beyond visual line of sight operations. UAvionics has certified and certifiable communications, navigation, and surveillance avionics for your aircraft. So head over to uavionics.com or Google it to see how you can start flying safer and move your platform forward into shared airspace.
So let's get on with it. So Luka, start us off with a bit of background on what has helped to set the stage for today's advanced air mobility.
Maybe a good way to start the conversation, and we won't spend too much time on it just because we introduced this story in episode 1 of our podcast, but figure it's a good way to start, and we can revisit the story that goes back to the late 19th century when Mary Ellen Stafford was born. And it's an important story to underline again because it just shows the astonishing rate of progress in aerospace and broad mobility that she experienced just in her own lifetime. And so when she was a young woman in the late 1890s, her family moved to Oklahoma in a covered wagon. And then a couple of years later, the Wright brothers had their historic first flight in 1903. That kicked off a very rapid pace of innovation. And it's an innovation in mobility that wasn't just limited to the third dimension, to the air domain, but also in ground mobility. And so in 1908, notably, Model T was introduced, and those covered wagons that Mary's family moved to Oklahoma in over time gave way to cars. And then soon after that, not even 20 years after the Wright brothers' flight in 1927, Charles Lindbergh has the historic first solo flight across the Atlantic. And when he was greeted by the crowds in Paris 33 and a half hours after taking off from New York, it was just a massive river of people, about 150,000 people that came out to greet him. And what he did is really plant this idea in people's minds about this new freedom of movement, this personalized, spontaneous flight. As we'll see, it hasn't quite evolved in the traditional aviation history that we know. It hasn't really evolved that way, but it's important for the current times that we'll get back to. Anyway, 2 decades after that, humans flew faster than the speed of sound. In 1958, we had the first U.S. jet airline that went into service. And then in 1969, Mary watched her son, Thomas Stafford, who was an Apollo 10 commander, strap on a rocket and go to the moon. And so we have this arc of going from a covered wagon to a rocket ship, all within Mary's lifetime. And the reason why we bring this story up and why it's important and why it will become important as we continue our discussion today is that it really highlights and forces us to think about not just the rate of progress, but the risk appetite that existed in the community, within the customer base, within the engineers who were at the forefront of development of these technologies, and the kind of impact that this had on the US competitiveness on a global scale, the mindset of the people, the patriotism. And so this is a backdrop that it's important to carry forward as we talk about advanced air mobility.
I think one of the things that probably drove the advances during Mary's time was that there were so many opportunities to be able to improve transportation, and the technology, kept up the pace for the improvement in overall transportation. Do you think those same opportunities exist now?
As we're seeing right now, we're back into the visible changes to the system and to the community, which is reflective of the first 70 years of aviation history, thereabouts, which we call this visible progress, where there was tremendous amount of step changes in terms of what airplanes look like, the engines, the systems, but also the visible impact that aviation had on our lives and how it connected the world and how it evolved into this mass scale commercial transport system that we know today.
There was clearly an opportunity for transportation to grow that the technology, kept up with. I think one of the things that our audience is listening for is, what are the significant value improvements to our system? What's driving the need for this next level of technology? Mm-hmm. I don't think many people question that there are many advances. The question will be, what will we realize? What is Mary's, what is the next person going to realize as to the improvement in our transportation system for these next level of advances that we talk about a lot?
When we look at the introduction of flight and the early uses of it in the early 20th century, it wasn't making existing wagon routes more efficient or better, but it was introducing completely new kinds of movements and an efficiency in the networks that you can then architect and build around. Obviously, there were other catalysts. There was the major wars in this early sort of first 70 years of tremendous progress in aviation. But the parallel to the times that we're in right now is that, and sometimes this gets missed, is that we're not just talking about introducing new technology to make existing movements more efficient, faster, better, cheaper, but rather, again, we have the opportunity to deploy these technologies in ways that we haven't really been deploying any technologies before, in terms of moving goods and people and their impact on our daily patterns of life.
Luka, talk a little bit about this, what some of the exponential advances in computing and materials and the like that you have referred to as the potential second Cambrian explosion, and why it's relevant to our audience.
The last 50 years or so in the history of aviation, we have witnessed this invisible progress, which was very astonishing, but it was things that we can't really point the finger to visibly. So things like computing and energy storage and materials and sensors and software. And aviation is not the only place in the economy where we have seen this invisible progress. And so the advances in all of these advanced technologies have finally, as it relates to aviation, reached certain thresholds of performance. They became good enough, both in their performance and form factor and affordability, to make certain new concepts possible. So the miniaturization of air vehicles and things like commercial drones, all of that became possible in, call it, late 2000s, early 2010s. But to your point, Jim, we've seen the same trend unfold across other industries, from commercial space, where we have reusable rockets that land themselves, and the access to space that they enable, and the resulting proliferation of satellite constellations and the supply chain that flourished around that movement. We're certainly seeing that in robotics broadly. We're seeing this to a certain extent in ground vehicles and in advanced manufacturing, just to name a few. And so the underlying enablers of all of these different manifestations are, somewhat not surprisingly, very, very common in their nature, and they're predominantly software and data based. Those enablers are now driving this, what we call the second Cambrian explosion in aerospace, where we expect to see progress like Mary did in early 20th century. And we're looking ahead to this, multi-decade transformation of aviation as enabled by these new technologies.
We talk around these software and materials technology enablers maturing to levels of performance where they're suddenly driving a new wave in aerospace and transportation. But the parallel to the past is interesting because, the first wave had its own technology enablers. Go back to the early 20th century, we were making fundamental advances in manufacturing. We went from handcrafted and fitted individual parts into mass-produced interchangeable parts. Incredible efficiencies of scale, coupled with improvements in precision, upon which we likewise advanced aviation and engine performance and aerostructures, from wood-frame, fabric-covered aircraft to aluminum-framed and skinned aircraft. And on the back of mass production capability, we saw, an incredibly short 20 years, going from 1927, Charles Lindbergh across the Atlantic, to the groundbreaking and iconic DC-3 in 1935, and then in 1947, Chuck Yeager breaking the sound barrier. It was the late stage of the Industrial Revolution, just before the Information Age, and the industrial base, with its foundation in mass production, honed in the automotive industry, drove these aviation advancements, and frankly was a huge contributor to the Allies winning World War II by outproducing, for instance, the German industrial base, that despite exquisite engineering, they still relied on highly skilled craftsmen to manufacture. So now, here we sit. This is the fourth industrial revolution. Underlying technologies that have been gestating for 50 plus years, where they've had profound impacts in other industries and society as a whole. Now, finally, we're seeing them crack into aviation, transportation more broadly, and ultimately, perhaps, to bring about the level of change in our physical world that Mary witnessed in her time. And to anyone who listens to this podcast, it's obvious what these changes are for aviation, right? But my point is that the trajectory ahead will be reflective of the technology drivers. Manufacturing prowess drove us from barnstorming biplanes to the 747. Software, autonomous systems, electric propulsion, mastery of nano and metamaterials drive us to drones, passenger autonomous flight, and fundamentally a new perception of the space-time around us, because these new platforms weave aviation into our lives outside of major airports and long intercity routes. It connects the, quote, faraway places in our everyday lives, bringing them near, making them suddenly convenient. And we can only speculate how this capability is going to be ultimately deployed. But also, for anyone who listens to this podcast, we all know it's not all sunshine and limitless horizons. It's actually a beast of a task to get these systems into the market. The United States of today is a highly regulated, highly litigious, and bottom line, very risk-averse society. We've sunk huge investments into the status quo across our mature economy, and this is a very, very different situation than we had here 100 years ago. It's just not a given that we'll see equivalent leaps forward in 20 years, and there are many recent examples of failure on that front.
One of the things that we're going to, in a few minutes, we're going to talk about the 4 points we discussed at the Honeywell conference. And one of the points that we talk about is the role of government. There could be skeptics on this podcast right now who will say, listen, during Mary's time, there were significant use cases that had to be addressed that were addressed with these advances in technology. So things were, built better, faster, and cheaper. Significant advances in air travel occurred. But could be people on the podcast right now, especially if they were more skeptical, some would say in advanced air mobility, it's technology in search of a use case. If we did see this second explosion, we see the technology, what do you think are, just give me a couple of major bullets that somebody will say that was the value that came for this next level of advancement in aviation and in transportation? What would they be?
It's a great question. Well, I'd start with the assertion that we really don't know today. And I say that to put a point of contrast on some very prescriptive visions that vertically integrated companies are pushing into the market. And that's where I'm skeptical. That our community can engineer magical new aircraft, it doesn't mean that we can necessarily read the future as to how they'll best be employed. And nor could the designers of the iPhone, for their own situation, do so either. Yet, these guys, they're taking a cue from the value chain in commercial aviation. They want to capture the profit from providing transportation service. I get it. But that leads them to have to design, certify, and build the aircraft. And today that means also the propulsion and major subsystems, and also to be the operator on routes that they select and control. And let's face it, that vision is more than a little bit informed by science fiction and popular culture and a lot of the influences that we've had throughout our lives. It doesn't mean it's actually going to be what happens. In my opinion, it just adds unnecessary risk to the equation. These are transformative new aircraft that can serve so many potential uses across different geographies, different circumstances. But between the eVTOLs and the drone delivery and cargo guys, these companies are the face of new aviation, of our industry, and Godspeed to them. We need them to succeed. So, Jim, at some point I'm going to come around and answer your question, but I think it's hard to know what our future selves will look back on and say were the killer use cases that AAM delivered. I think if we bring a shred of humility into the question, we'd recognize that based on the history of technology paradigm shifts and the complexity of our diverse economy, that we really can't pretend to know today before these things are in the air and scaling in the hands of end users and customers. So what's the path to the ultimate answer of the killer application for AAM? I'd say just put the technology in the hands of customers and learn from them and watch how they put it to work, learn from that. We can be sure that they'll educate us, they'll probably surprise us, but they understand the particular problem that they're trying to solve better than we ever could from arm's length. But if we don't give them the products that are adaptable, that they can use, that they can control for their own purposes, I think we as an industry simply delay receiving those insights. So I think the way to do it is to give customers aircraft that they can use on their own for their own purposes. That may mean more multi-purpose, multi-mission aircraft that are more accessible to a broader swath of customers, perhaps that already fit into existing pilot training and operations regulations, but not in all cases necessarily. But overall, aircraft that we can get into the market quickly, aircraft that are operated by customers and that in a way, through their simplicity, are suitable to a wider range of missions. Our industry is spending billions on tightly constrained operational concepts that haven't yet been proven to be really what the market wants. So we should think about how we can bring forward products that reduce the risk that, we didn't get the ConOps exactly right the first time. And I think that from that, call it more modest starting point, we're going to learn a ton. And in the course of that, we'll build the industry muscle and experience and access to capital based on what customers are unearthing as the real killer applications, to bring forward more aircraft specific to the demand.
And I would also add that I'm not really sure, Jim, that in the early 20th century, people had a very clear idea as to the use case that they want to deploy aircraft into. That's evident in the struggles that the Wright brothers had in selling into the U.S. Army, for instance. There was was a lot of skepticism around these new vehicles and their true impact on the battlefield in the transportation system. So much so that after World War One, where there was a lot of aircraft and a lot of pilots that came out of the war that didn't know what to do with
Very good
the
point.
aircraft, they started flying in shows and
I remember reading
Barstow.
I remember reading the Wright brothers book, and I couldn't believe that the use case of the aircraft, had to be, they had to convince them as to this is what you could do with these things. So it's a very good point, Luka. It's very analogous to today with what some people believe as it relates to advanced air mobility. Good point.
And I also think it's a lot easier today because we're not reintroducing aviation for the first time. What we're doing is lowering the barriers for people to participate and leverage the third dimension. That's a big difference.
And a point that Peter's already made, and a point that we addressed in the 4 points, but we're introducing it to an established, highly safe system that's very disciplined. And they've done it right for many years. And now they are going to be very critical of these new vehicles that come to the space to make sure that we maintained our high standards. This is both a challenge, it's an opportunity, which we're going to talk about. Could you talk a little bit about, so here we are in the 2020s, and a lot has changed in the last couple of years, and it's obviously very influential to advanced air mobility.
Certainly. Suffice it to say, we're just 3.5 years into the 2020s, and it's already proven to be a decade of huge surprises. I can't think of a time in my life where the sense of uncertainty for the future has been greater. It's across the spectrum. I really think of it as two categories or sources. The first being the velocity of technological change and its resulting societal changes. And the second being feeling like we're continually getting blindsided by global events. We've had a pandemic that disrupted supply chains and still dislocates the economy. Climate change is pushing transformative shifts in transportation and even how we consume. Global powers are squaring off against each other with the real prospect of direct conflict. And the war in Ukraine is an example of how warfare itself is rapidly adapting to and exploiting new technology. And most recently, on the technology front, breakthroughs in generative AI look to be the most exciting technology development in over 2 decades. They promise to deliver productivity gains that are likely to disrupt job roles across the entire knowledge economy and simultaneously bring what may be a rapid wave of unintended consequences and nefarious uses that we're going to have to deal with. So yeah, it's exciting to wake up every morning in the tech world and see what new things have unfolded. Creative destruction in a way, but the velocity and uncertainty are wearing people out, straining society and how we bond with each other. I'd say at best we're reacting to this, but we're certainly not ahead of the curve. Feels more like we're along for the ride. So it's against that backdrop that, this nascent technology called AAM is coming to market and starting to touch people. The pandemic and the war, I think, served as a demand signal for AAM, pushing its development in a way to solve logistics problems, as one example. We can already see where AI, I think, is going to have a huge impact, and perhaps not on the safety critical path for flight operations, but certainly in managing the avalanche of data that supports operations and also in the development and testing of next generation systems. But in summation, this all adds up to uncertainty in projecting the future, and it really underscores the wisdom for all of us of baking in flexibility to our particular vision, perhaps a vehicle or a con ops, to de-risk and not leave ourselves exposed to what might be the next surprise around the corner.
So this is all, I think, a good introduction to the 4 points we talked about at the Honeywell conference. And so why don't we do this? Why don't we just talk about those 4? And while we do it, and obviously these are observations that we've received from our 45 plus guests that we've talked about. And they're also observations that we have seen and we've realized over with our own businesses over the last several years. And then also while we do this, we'll give some feedback we surveyed our guests going into this discussion. And we asked them certain questions relating to these 4 points. So we'll introduce some of the feedback from our guests as well. So who wants to take the first point of the 4 that we talked about at the Honeywell session?
The first takeaway reinforces the importance of flight experience for companies that are developing any aspect of this technology. At Radius, we've taken on this mantra of follow the flight hours. And that encapsulates the idea that getting into the air and building experience really pushes an organization forward, really helps mature all of the systems and the way they work together, to flex the organizational muscle, to build experience in the team, stress systems end to end and push their maturation. And through all of this, build up data that gives the company confidence, gives the regulator confidence, and gives investors confidence and thus access to capital. I think that flight experience is showing itself both for the companies as well as for the regulators to be a really valuable currency for understanding the true requirements of these systems and being able to assess statistically from real data the safety and reliability and performance envelope of these systems, despite their internal complexity.
So why have some platforms benefited or have been able to fly for the number of hours that you've talked about where others have not? What has allowed them to do so in this obviously very complex aerospace that we're talking about?
Well, in some ways, it depends on the nature of the mission that they intend to fly. And another really important factor is the size of the air vehicle, especially if it's a startup driving the effort, which naturally is always resource and capital constrained. Everyone gets the value of this iterative process and wants to see it happen, but it's the smaller air vehicles that really accommodate the rapid accumulation of experience and rapid improvements in response to the feedback loop. They're faster to build, it's cheaper to build lots of them, they're cheaper to fly, and faster to modify and improve. Everything happens faster when your flying object weighs, say, 40 pounds instead of 4,000 pounds. And yet, with respect to many dimensions of the AAM integration challenge and the path to market, the experience gained in the small systems transfers to the rest of the industry.
So, Peter, tell our listeners, give an example of these small aircraft that are flying a lot and they're proving out a certain use case, and give them some examples, because at the end of the day, that's what most of us are reading about today.
One example that is definitely out there is last mile delivery using drones, be it for a medical use case or a consumer use case. You look at the experience that Wing and Zipline, Drone Up, and Mana Drone Delivery have accumulated. Cumulatively, we're talking about close to 1 million flight operations completed. Some are in a closed testing environment, but one that's representative of the real mission under different operating conditions, different weather conditions, different vehicle states. And some of these flights are in front of customers in test markets where the company is able to not just assess the reliability of the system, but also to learn from the customer how they want to interact with drone delivery, how that feeds back into the requirements of the mission, understanding how to respond to contingencies, getting a chance to experience failures in a component or at the network level, and iterate rapidly back into the engineering to advance the maturity and resiliency of the system. Now, in terms of the business prospects here, well, we know that there are markets. Demand, that data is in hand. The question on people's mind now is the unit economics. Can those close? And also the cost of scaling. There's a case to be made here, but let's see how things unfold. I have reason to be confident. But if we think about all the flavors of AAM, drones transporting cargo or making some kind of delivery are going to be what touch the most people worldwide the soonest. They're going to give them their first experience with this technology in an outsized way compared to everything else.
And generally speaking, they're flying in areas where there are not other air vehicles very often. They're not flying passengers. So the level of certification required for these vehicles, I would assume, is quite different than passenger carrying vehicles.
We're also seeing some really positive signs that regulators across the world are starting to embrace this value of empirical evidence. Here in the US with the FAA's durability and reliability certification process. Similarly in Europe, we are seeing that whereas in the past, OEMs had to show compliance with certain requirements in a design manner. Now they can leverage the operational experience to show compliance towards those same requirements. In other words, now in Europe, operators can graduate, quote, from SAIL 2 missions to SAIL 3 missions and self-certify, provided they show enough evidence of flight and reliability data, as opposed to going through the design verification process to be able to operate in SAIL 3 missions. And that is a significant milestone.
So follow the flight hours is really what we're talking about in point one. And there's been a lot of flying, and you're saying there's all kinds of value that comes from these flight hours. Could an argument be made? Okay, a skeptic again. Could a skeptic say, well, yeah, but those are in places that are really irrelevant, and a lot of it's within visual line of sight? Have we really made the advances in beyond visual line of sight in areas where there's more complexity, there's more vehicles, and you're even getting close to, those vehicles carrying passengers where the real case is? How do you address that?
It is a very relevant and good question. And I think it boils down to the combination of ground risk and air risk. And so there are elements of ground risk that you can show pretty much anywhere on the globe if you have a good data collection and analysis and logging practice that you can then take and show to regulators in a way that they want and need to see it. The trickier part is the air risk mitigation, because companies that have gone to places like Rwanda or Ghana or more rural and less complex airspaces, it is a lot tougher argument to take that experience and then come to the most complex airspace in the world with a national airspace system in the US and say that you'll be able to do the same. The bar is higher there, and it comes down to how do you address air risk in a way that, again, makes regulators comfortable.
And Jim, the way that you posed that question was really interesting. The skeptic would say these types of drone cargo operations are not significant until you get to operating in the most complex airspace. Okay, I don't agree with that skeptic, but for the moment, let's look at the path to operations in complex airspace. The first category is you need a robust air vehicle, and you need a deep understanding of what is fundamentally a new, unexplored mission space. How precisely will operations work? What do the supporting systems need to do? The second category is you need airspace integration with an airspace system on the level of complexity and maturity as ours here in the US. Okay, for the first category, you can go and develop that in simpler airspace, in some geography where the mission risk is lower. That effort takes the iterations and the accumulated data to see all the corner cases and drive reliability into the system. I think that that's an idea that's been proven out by the pioneers who have gone and done just that. For the second category, airspace integration, that's where the test corridors in the US come into play. They've really built up sophistication over the years, and if you really already know your mission and have exercised your airframe, these test corridors can be really effective in exploring airspace integration questions across surveillance, traffic, communications, and security. And for those lower risk operations, I think that there's a lot of ground to cover in more remote areas that are poorly connected by existing transportation infrastructure, provided that you can make the unit economics work. Use cases where the drone can create a new link, a bridge in effect, can really thrive in those remote areas. And, the bulk of the decision makers and the leaders in the advanced air mobility community tend to live in large metropolitan areas. And maybe reflective of that, the focus is towards making the drones work in those areas. But I really believe that around the world, there's a lot of fertile markets to bring the technology into and create a sort of leapfrog effect in logistics, driving the public good and driving commerce.
You're right. One of our guests, and I don't remember which one it was, talked about medical logistics and the couriers. And so what they said is actually there's greater value in the more rural areas that would otherwise be served by a car, where you had to dedicate people to a car for long drives, where here the immediate value of medical logistics and courier transportation were in the rural areas versus the urban areas. So we talk about the value of volume throughout the world, and I could be wrong, but it sounds like you are talking about a lot of places where people are doing a lot of flying, Luka, but I didn't hear a lot about the United States. Why is that?
Yeah, that's a good observation. When we look at where this flight experience is being accumulated today, it's not really in the US. Companies are going to places like Australia, some of the African countries that I mentioned earlier, Ireland, or other countries in Europe. And that primarily is as they navigate the most favorable regulatory pathways to ultimately obtaining this flight experience. And so, yeah, the US is behind from that respect. And even at Radius, being a US based fund, a disproportionately large portion of our deal flow as it relates to the drone ecosystem at large is coming from Europe and Israel because of that. And one way to generalize the state, and quote by Mark Twain jumped to mind, who said, all generalizations are bad, even this one. So we have to take this with a grain of salt. But I think it's fair to say that when it comes to the market opportunity and the size of the pie, the US is ahead. When it comes to the technology development, this is a bit of a mixed bag, because in the US, there has been tremendous and still ongoing tremendous technology development, especially as it relates to the military domain. And if we look back to the last couple of decades of the global war on terror and the military technologies around unmanned systems and remotely piloted systems that have matured around this military effort, it is remarkable, the level of technology development. However, the technologies that require the kind of rapid iteration and the kind of accumulation of flight experience that we just talked about here, obviously it's lacking in the US. And then finally, as it relates to the regulatory aspect of clearing some of the more complex drone operations, like flying beyond visual line of sight, the regulatory framework in Europe is much more permissive and offers a framework for operators and OEMs to follow in a way that is of progressive risk. So no surprise that capital and talent is gravitating towards places where regulatory landscape is more clear.
So one of the questions that we asked, by the way, I'd love to talk a little bit about UTM as it relates to all this, if we have time, because the United States is, as I think Chris Kucera said, it's just a different model, and so that obviously could be having an effect. But we asked our guests, our previous podcast guests, what their impressions were as it relates to what the United States be behind. So one said, while the U.S. may be behind in advancement, they are ahead in safety. In several countries, they said, there is a significant emphasis placed on being first and not enough on being safe. Too much hype and not enough reality. The U.S.'s slower approach will save lives. Somebody else said, yes, but much of the rest of the world, Europe, Japan, and Australia, has moved to regulatory frameworks that set oversight proportional to risk. The U.S. is currently all or nothing. Drone delivery requires the same framework, for example, Part 135, that is used for passenger jet charter. And then somebody else said that the U.S. may appear to be behind, but the more measured and calculated safety approach that is being taken in the U.S. will yield more permanent and scalable applications of advanced air mobility and drones. What are your thoughts?
I have to say, it's been a surprise this last couple of years to see this shift in where company formation and new innovation in the drone space is happening. The shift we're seeing to Europe, to Israel, and Asia Pacific. Or to put it more succinctly, the fact that we're not seeing a dominant proportion happening simultaneously here in the U.S., outside of defense at least. It wasn't that way just 7 or 8 years ago. It was U.S. companies then that were forming, and they were heading overseas to do flight testing and development, but with the strategy to return to the U.S. market. What's happened since then is they've developed a lot and come back, but it turns out the U.S. regulatory framework isn't ready to accept them. It remains incomplete. However, during those years, Europe built a graduated regulatory framework with required integrity levels that were responsive to the risk level of the mission proposed. And that has at least created a path for companies there to go to market. And so now you see even American companies like Wing investing more in their capacity build out outside of the US, in Australia, in Ireland, and in other European markets. So with respect to the comment that, the US approach is going to yield higher safety levels and save lives, perhaps it's hard to argue with that, but I don't think that that was the reason that the US or that the FAA has taken the approach that they've taken. I've heard arguments that it comes down to really some statutory restrictions that the FAA is subject to because they have to make rules reflective of the law that authorizes them, and that there was an assessment that going and taking a more SORA-based staged risk approach was something that was outside of their purview at the time based upon the existing code. Okay, that's fine. I know that there continues to be ongoing debate in the U.S. regulatory structure around the merits of a SORA-based approach, but I do think that we can see that the staged risk approach being implemented in Europe is yielding results. We're seeing companies make a lot of progress in their systems, and I think that that's accelerating progress towards the scale up of a safe industry. And in every company that we've dealt with, every single one of them is not stopping at the missions that they're focused on today. They're not stopping at low and medium risk missions. Their product roadmap is solidly focused on achieving maximal levels of safety. And these companies are doing it out of their own self-interest because they, I think, intuitively understand that that is going to be a competitive pillar on which they're going to base the future of their business 5 or 10 years from now.
Hey, let's go to our second point. First of all, I'll just say as a commentary, I thought that was a very novel comment that there's value in volume. That's where you're first focused on. And frankly, it's a bit of a shame that we can't lead this as a country and that we're following, especially given that you could argue with the small drones and the like and where they're flying and the high value of where they're flying and the low risk. This is an area many would say that we should be leading. And we heard that from a lot of our guests. What's our second point?
The second takeaway we encapsulate as thrive on the way to the green light. And what we mean by that is, from an innovation standpoint, the green light is the regulatory green light to get advanced air mobility platforms commercialized and scaling rapidly. That's the starting gun for the next chapter of this industry when we really start to scale out. All of us in this industry are looking for when and where this regulatory green light is going to occur. Will it be in drones, in eVTOLs, in regional air mobility, or electric aviation for the GA market, in Europe, in the US, et cetera? Lots of companies are waiting for this because it's when their revenues can really kick in. So the highlight here is that there's another set of technology opportunities that are growing their revenues ahead of AAM scaling. Their value proposition is actually as an accelerant towards the levels of system integrity and safety and performance that these platforms need in order to be able to enter the market and scale. So an example is development tools for complex cyber-physical systems, like an automated aircraft, that involve both software as well as mechanical aspects. Or another example is the role of AI in generating and managing the data that fuels these systems in terms of safety or managing operations. We see a really interesting area of innovation that is a today market. These will accelerate advanced air mobility towards scale, but also have numerous adjacent markets outside of aerospace that they're being applied to.
One area that I've always been intrigued with are the technologies that apply to advanced air mobility that also apply to the rest of aviation. So in other words, it introduces it to a far larger market. Can you give some examples of technologies that are getting us to the green light faster, but also have a broader application? You said even outside of aerospace, but how about other parts of aviation and aerospace that would also apply in addition to advanced air mobility?
Okay, let's look at the software industry as an analogy. Over the last 5 decades, software development tools have massively increased in capability to the point that today, even a small, lightly capitalized startup can build astonishingly complex software. They can build it in an agile methodology. They can deploy it out to their customers and continually update. And the reason that they can do that has a lot to do with the development tools. The evolution from early 1970s command line compilers and manual debugging through to integrated development environments, through to networked development and DevOps deploying to the cloud. Now, developing a drone or an aircraft or a robot, a system that has a lot of software but that software is embedded in a physical system with interdependent mechanical design aspects and aerodynamic design aspects. It all has to tie together to perform and deliver reliability. It has to be manufacturable. And of course, it has to pass through all kinds of gates verifying the safety and reliability for certification. It's a multidisciplinary development process, yet with pervasive interdependencies throughout. Today, it's held together with a lot of manual involvement by engineers. It's a huge contrast from software development. And there's a lot of room for improvement and a lot of work being done right now to expand the power of our development tools based on the example set by software. Push that workload and complexity back onto development tools and move the time spent by human engineers onto higher value tasks. This is a generalized capability. It might be getting pioneered in aerospace, but also pulls from advances in automotive and has applicability across many industries.
Were any of these capabilities born from advanced air mobility, or is the AM benefiting from them?
I think it's both. In ways, they are born from work done in aerospace and defense, some directly in advanced air mobility, but this technology also has roots in the world of racing as well as I mentioned, in automotive.
And what Peter is starting to describe here is really the investment strategy that we have at Radius, which is really at a high level about technologies that are both underpinning and benefiting from this mega trend of software and data increasingly shaping the physical world. A lot of these solutions and things that Peter is describing is some kind of derivation of advanced technologies, including AI technologies. And just in our portfolio, this is reflective in the ways that that technology is used to increase the transparency, for instance, in ground operations at airports that lead to improvements in efficiency and safety and sustainability, or applying large language models to a really palpable problem of geospatial data search and correlation, or taking these AI-enabled digital environments to a large extent develop and test and even down the road certify complex systems entirely in models and simulations in digital domain.
If I remember correctly, I think it was Pasha from Alaska on our podcast who mentioned the use of a lot of these same capabilities on the surface and the efficiency, gaining that 5% almost immediately using these AI capabilities. In fact, I think we're going to have a guest coming up in a couple of podcasts where some of these technologies will have an immediate effect.
It's pervasive, right? We talked about this with Jesse Coleman and Will Roper and Scott Drennan and others, that just highlights how foundational some of these building blocks, some of these enablers are, that you can take them and apply them to things like a small drone that fits in the palm of your hand. It can also be applied to a traditional large airliner. It can also be applied to an industrial robot in a totally different industry.
When we were at Oshkosh, I saw the demo I think it was at Honeywell. Now, if I could be wrong, but I think Josh said this on the Honeywell podcast, that everything they are deploying in advanced air mobility also has applications throughout other aspects of aerospace. In other words, nothing's being dedicated just for AAM. So what a great example of their platform that Honeywell's built that applies to at least some other areas of aerospace. Guys, let's talk about the third takeaway, and it talks about the battlefield. I think this is probably an area that people would probably have a little bit of a better understanding of, but if you could give us an overview.
The takeaway here is that the same set of enabling technologies that we have been talking about so far that are shaping aviation and other domains, those same technologies are also defining the battlefield. And so what we are seeing in the war in Ukraine, what happens when the warfighter, in addition to having access to traditional military assets, now they can also leverage powerful, affordable, and very accessible new enabling technologies. And what happens is that the warfighters start to look like entrepreneurs in terms of iterating on the products very, very quickly, building a product that just crosses the minimum viable level of capability and then putting it to test, putting it to use, collecting the feedback, repeating the cycle. And so in many ways, it is behaving like entrepreneurs. None of us who have been in the industry and observing the growth of remotely piloted aircraft and how they're being deployed in the military, I don't think that there's much surprise that drones are playing the kind of prominent role that they are playing. I think the surprising part is the scale at which this is happening and the kinds of collaboration between traditional military and commercial sectors. They are converging in a way that is both very exciting, but also in ways that is blurring the boundaries of traditional warfare to the point that how do you classify a commercial constellation of satellites that is providing imagery or providing a connectivity backbone? Are they a military combatant? What are the implications of that? What about their assets around the world that are supporting this capability? So the boundaries are definitely blurring, and the scale at which this is unfolding is really, really interesting to observe as well. And that is a surprise. Another thing is, who would have thought that here we are in 2023 or, even 2022, and we're observing a war that involves one of the most powerful militaries in the world. And who would have thought that this conflict would look like the artillery trench warfare of World War I? That's kind of what happens when traditional military doctrine no longer has product market fit, if you will, when you fail to respond to a situation where there is unprecedented situational awareness on both sides that are often coming, as I mentioned before, from commercial actors, and where you have mass harassment from lethal power in really small packages, and where you have these advanced AI-enabled complex cyber physical systems that are doing their best to get inside your kill chain. That's a trend that will only continue to get even greater and greater. We can throw stones and poke holes in the use of drones and say that, hey, the effects are not really there. You can't really do a lot with the drones at this point. And, the larger tactical UAS systems are vulnerable to some of these integrated air defenses. Small drones are not really likely to result in any significant offensive effects. You can also say that, hey, it's questionable how much of what we're seeing in Ukraine can translate to other theaters now that some of the lessons have been learned. All those are valid criticisms, but I think what is undeniable and what is kind of scary is when we extrapolate this trend and project 5 years from now, 10 years from now, what the battlefield looks like and how those technologies continue to evolve.
When we asked our guests, what's the effect of the AAM on the battlefield, one said the ability to overwhelm enemy defenses with internally coordinated swarms of cheap systems is something that we need to be prepared for. Somebody else said that we'll have a hyper-targeted strike capability without placing humans in danger. So this is how arguably the battlefield has changed or will change. Could you make the argument that the use case for the drone is very obvious in the military, and that's why it's taken off? It's very obvious on today's battlefield, and that's why it's as commonly used as it is. And then number two, could you make the argument that the value is so great that the risk involved is considered a fair trade-off?
I think that's exactly it. One of the reasons why we're seeing such tremendous advance in UAS systems and related technologies in the conflict, it's because the risk-reward equation is so much different and the risk tolerance is so much higher. And it goes to the previous point of this is what happens when all of a sudden you open up a river that hadn't previously existed and you lower the barriers to air power. Traditionally, it has taken a wealthy nation to have precision airstrike and to have ISR capability that is persistent, that is actionable, et cetera, et cetera. It becomes within reach. It becomes accessible to everybody. You can put an FPV one-way drone together for a couple $100. And so it really provides this, asymmetry and accessibility to air power that hadn't existed before.
I think it also ties back to the question of, If we know that the industrial base of a given country is key to winning a war over time, what does the go-forward industrial base need to be composed of in order to sustain and win future conflicts? Certainly, one of the lessons of World War II was that mass production capability in the industrial base was paramount. The U.S. was really good at it. It may not have been the most exquisite level of production. It may not have been systems built at the highest levels of tolerance, but it produced overwhelming volume of material and had the ability to sustain the Allies throughout the war. And remembering that war is ultimately a contest of wills, even after the exquisite aircraft and cruise missile and naval platforms have been expended, people still want to keep fighting and will with whatever they can produce and bring to the fight. Currently, Ukraine is in many ways reminiscent of warfare 80 or 100 years ago, but it has this overlay of cutting-edge lethal technology in small packages, for instance, in the form of a drone or a Javelin missile or shoulder-launched air defenses. And in some ways, packaging lethality in small packages has geopolitical advantage. In the early months of this war, at least, it certainly was politically more palatable to support the Ukrainians with things like thousands of Javelin missiles and shoulder-launched surface-to-air missiles, and it turned out they had a decisive impact on the early chapters of the conflict. But in contrast, a couple dozen 40-year-old multi-role fighters like the MiG-29 was politically unacceptable to throw into the fight. But winning such a conflict requires the industrial base to be able to rapidly scale up and sustain production of the cutting-edge technology. And we're finding that hard, even for lethality in small packages. And AAM is playing such a malleable role in this conflict and being exploited with new tactics that in turn feed new requirements that I can only envision its role in future battlefields growing. And if that's true, then what does our domestic industrial base need to look like to win and thereby deter future conflicts? The domestic drone supply chain is thin, and underlying components are often foreign. We need to look at the question of the industrial base comprehensively across the full extent of systems that we'll need to sustain in an indefinite conflict. And just as the domestic automotive industry pivoted to military production in World War II, we need to understand what goals we should have for the domestic drone and AAM industry base through this lens.
This is a complex topic. It's a broad topic, and clearly there's value here in the war of Ukraine that in advanced air mobility that we haven't seen as much in other areas. What have we learned from the war of Ukraine that would apply to commercial applications?
There's been really interesting progress in GPS denied navigation and just broadly positioning and navigation that I think has applicability and relevance to commercial use cases. The robustness of data links is probably another interesting area. And not that we are seeing this so far in Ukraine, at least my knowledge is not completely up to date, but several months ago, when I looked at this space in a bit more detail, there was no evidence that either side of the war is employing true swarm autonomous tactics. Whenever drone swarms are being mentioned, it usually means multiple drones operated by a single operator. But that's really not what we're thinking about here. But this will come very soon. And the experience with drone swarms and technology that supports it will also have great applicability to a lot of commercial applications as well down the road.
And I would add to that the role of social media as an information source on the state of affairs in the combat theater, and the fact that anybody with a cell phone can be a source of live information about the situation on the battlefield. That's a new dynamic that comes with its own potential and pitfalls for that matter.
Yeah, they also become forward observers, which makes that civilian a tactical threat.
Yep. And then, likewise, that information channel can be spoofed as well, and it can be filled with misinformation. And so in that way, it takes on a whole additional dimension in the conflict.
Guys, let's talk about the fourth takeaway. The traditional regulatory practices applied to new technologies may lead to unintended consequences. This is a cool topic.
Yeah, this is really interesting. The title of the takeaway that you just laid out, Jim, relates really to the scope of regulation to include not just safety, but also global leadership in this industry and its implications for national security. As we brought up earlier in the discussion, we're in a period of accelerating technological change. The rate of advancement means that almost everyone is experiencing some level of changing roles. Pilots, controllers, maintainers, and certainly the companies building new businesses. Even the FAA is experiencing a change in role, and likewise must consider anew what it means to drive safety in the airspace system when the airspace system plays new roles, sometimes life-saving roles, in the lives of the general public. All these factors combine to create a situation where applying traditional aviation regulatory practices can easily lead to unintended consequences and bad outcomes with respect to our national priorities. Getting it right will really require careful thought, I think reaching all the way back to first principles of the proper role of government in our country.
Regulators need to master new technology and give it the necessary urgency for its successful integration into the national airspace systems around the world. And that brings some really interesting considerations and discussions around the mandates of regulators. And this is something that we touched upon most recently with Dan Elwell about, certainly on the FAA side, how this mandate evolved from initially just being purely focused on safety and then adding the promotion of the industry as a secondary mandate, which then the FAA sort of walked away from after seeing that potentially caused a notable accident in the industry with ValueJet. So now we have to ask ourselves the question, in the face of all of this technology knocking at industry's door, what is really the true approach here when it comes to the diversity of the mandate? The point that we're trying to make is applying regulatory practices that work for traditional aviation might actually lead to unintended consequences when we apply them to these emerging technologies.
And then what's the most significant unintended consequences that you want our audience to know?
Well, it is the slowing of the global competitive edge of the United States is one of the most significant impacts. It's the slowing down of innovation.
Right. If we want to maintain our innovation edge and leadership in AAM, where it is evolving at a much faster pace than aerospace ever has in recent decades, then if our regulation creates rigidity that leaves us unable to flex the system to embrace new technology or creative new applications of AAM, then that's really a loss. That's just poor planning on our part.
Good, guys. We hit our 4 takeaways. It was really well received at Honeywell. Now we've told our vast audience. Is there anything else you want to leave with them?
Wasn't this enough?
Okay. Thanks for the talk, guys. Actually, one of our upcoming guests is going to be somebody who actually spoke at the Honeywell conference, and I think everybody's going to really enjoy his conversation. So thanks, guys, and we'll see you soon.
It's been great to be on the other side of this table.
Right.
Thanks, Jim.
All right, that's a wrap for today. Thank you for listening to the Vertical Space Podcast. Reach out if there are topics that you would like us to discuss, and goodbye until the next episode. Unless mentioned, this podcast is in no way endorsing or promoting any person and or company mentioned, and all opinions within the podcast are solely that of the presenters. The Vertical Space makes no guarantees, warranty, or representation of any information given in this podcast. Any information given is for informational purposes and should be used at your own risk. This podcast is for general, educational, and entertainment purposes only.